Okay, today we'll be talking about energy and the conversion between types of energy. You have two main forms or types of energy, potential and kinetic. Remember to do today's Cornell notes, which are going to be a little more complicated. You need to fill in the notes section. Some of it's filled in for you, but you'll need to complete it with definitions and examples, and then do essential questions and summary before class on Monday. Okay, so what is energy? Energy is the ability to do work. Everything that produces heat and or moves needs energy. Okay, how do you know work is being done? Usually you know work is being done because you see motion. So potential energy, we'll start there. You guys have reviewed potential energy before. You know a little bit about it. Potential energy is the stored energy that will possibly become energy in motion. Okay, this is your energy of position. So if you have a roller coaster at the top of a hill, it has potential energy, specifically gravitational potential energy. If you have a boulder on the edge of a cliff, it's not moving, it's potential energy. It could move. It has energy because of the position that it has. It's stored energy, but it hasn't begun moving yet. Okay, so there's certain kinds of potential energy. One type is nuclear energy. This is released by nuclear reaction. Some examples of ways we use nuclear energy would include nuclear submarines, the heating systems that generate energy based on the release of a nuclear reaction, and then the energy from inside of the sun is all examples of nuclear energy. Chemical energy is another type of stored energy. Chemical energy is energy stored in bonds between atoms and molecules. When the bonds break away, they release heat, light, motion, and or sound. Some examples: coal, oil, propane, and food. Let's take, for instance, photosynthesis. Photosynthesis. You have water and carbon dioxide react with one another in the presence of light energy from the sun, and they end up producing glucose and oxygen. Your glucose is a food for the plant, so your glucose has chemical energy. So in photosynthesis, you had light energy from the sun be converted into chemical energy in glucose. Mechanical energy is stored energy because it's the potential in items that want to bounce back into their natural shape, okay? If an item could move, it has mechanical energy stored. So if you have a rubber band that's extended, when you let go, it's going to want to bounce back into shape, so that's mechanical energy. If you have a spring, like a slinky, and you have it pulled out, when you let go, it bounces back into shape. Another type of potential energy is alternative energy. We're seeing a move in this in science because we're depleting our natural resources, our non-renewable resources. Well, alternative energy is any source of energy that can replace other types of energy. Alternative energy is renewable. Our examples are biofuels, solar energy, wind power. Okay, so I just discussed potential energy. Let's go ahead and discuss kinetic energy. Kinetic energy is the energy an object has when it's moving. So if there's any type of motion, that is kinetic energy. For example, sound waves. Even though you don't see something moving, you know that the waves are moving through the air. That's kinetic energy. Radiant energy. That comes from waves of electromagnetic spectrum. Like light travels in waves. Okay? X-rays are a type of wave. Radio waves are waves. All of these things travel in waves, like sound. Okay, these are all types of kinetic energy. They move, you just don't see it. Electrical energy. This is kinetic energy because electrical energy exists in the movement of electrical changes. Lightning and electricity that powers our homes. You know that electrical energy has to move through the wire when you plug in a toaster. It has to move through the cord to get into the toaster and power the heating elements to heat our toast. So we know that electricity moves, so it's a type of kinetic energy. Thermal energy. This is heat caused by the movement of vibrating molecules within a substance. Stoves and matches. Anytime you have heat being produced, the heat also moves in waves. That's why if you're around a campfire, you could stand back from the campfire and put your hands close to it, but still feel the heat without burning yourself. So here's just a little way to remember the forms of energy. You have nuclear, chemical, mechanical, alternative, radiant, electrical, and thermal. So what you could remember is this little mnemonic: never come meet a really energetic toddler. Okay, N is for nuclear, C for chemical, M for mechanical, A for alternative, R for radiant, E for electrical, and T for thermal. So what you want to do now is make sure you have your Cornell Notes summary completed before you come to class on Monday. You have your essential questions down the side of your Cornell Notes, and any blanks in your Cornell Notes are completed. Rewatch the video if you need to. And finally, make sure you have your Cornell Notes on Monday so you can do our activity, and we'll be discussing energy transformation. Thank you very much.